So Hickson Properties has partnered with the Cavender family on 8.5 acres in this area. And as soon as we put that partnership together, we worked with Lake Flato and another group, Overland Partners, to help master plan this entire development. And at the time, Todd Washer and David Lake were really, really excited about mass timber construction. We talked about this office building really being the catalytic project for the entire area. And Todd and David said, you guys really need to consider mass timber. It's something new, it's sustainable, it'll set you apart. Other projects are coming online in San Antonio, and if we do mass timber, we've got something here that will differentiate us. With that, we started looking into it.
There was the development side of setting yourself apart, and then on the architect side and the sustainable side, we were trying to push the initiative of reducing our carbon footprint. And Lake Flato has done a number of these projects before the Soto, but Soto was on a bigger scale, and we really wanted to do that kind of bigger scale with mass timber.
12% of the carbon emissions in this country are put out by the production of steel and concrete. So if you're producing those materials, you're releasing carbon into the air. But the thing about wood is by nature, it takes carbon out of the air. And so you have a tree, it grows, and during that growth, it's breathing carbon dioxide out of the air. And then when you cut the tree and build with it, you've just harvested that carbon, or you've sequestered it. And so in building with it, we're actually taking all of that carbon that was breathed into the tree and we're storing it into the building.
Roughly 30% of all the carbon that's produced on a yearly basis in the U.S. comes from construction. 50% of the carbon in a building is coming from the structure itself. So it's really a good way to reduce the carbon footprint. And you can argue that in a lot of cases that mass timber buildings can be carbon negative just because of all the carbon they've absorbed during their lifespan. So it's a very old way of building that's become new again. The reason that it makes sense now is we've gotten so good with computer-aided construction that all of this wood is produced in a very high-tech way. So it's all wood, but it's, instead of being large trees that are cut as large sections of wood, they're, in all cases, smaller portions of wood, smaller cuts of wood that are all attached together either through glue lamination or, in this case, for the structure of the roof, through dowels that use absolutely no glue whatsoever.
The size of the wood is correlated to the age of the wood, and so that's the big difference from 75 years ago and even hundreds of years ago. When we were using wood, we were having to harvest really old trees. And so responsible forestry groups are highly in favor of this practice because you're using 10, 15-year-old trees that are forested and farmed exactly for this purpose.
You know, the feeling of the space itself. You know, when you look around and you see the wood exposed, you know, I think there's been a lot more understanding around the biophilic response that we have, and people being in places that are more closer to nature, where we, you know, grew up and evolved for, you know, thousands of years. And so it's a much more, I enjoy coming to this job site regularly and, you know, seeing the structure as opposed to looking at a steel or concrete column.
There's a lot more studies being done now about biophilia, and two interesting things I've read about or heard about at conferences. One, they did a study where they had somebody remove their shoes, so they're in bare feet, and stand on different materials. And when they stood on a wood surface, they noticed that their blood pressure went down and their heart rate went down and their breathing slowed. It's just a physiological response that humans have to wood as a material that we have known in our environments, you know, for millennia. And the other thing that they're finding is that just the surface of wood, because it's organic, no inch of wood is just like any other inch of wood. When you look at a wood surface, it's completely organic, and there's something about that we sense that makes us feel comfortable. If you look at something like a drywall wall, where it's all one surface, all one color, that's far less pleasing to us than a piece of wood where you can see the wood grain, getting smaller, getting wider, having knots in it, that gives us a connection that associates, even though that's a building material, we associate with that material with something that exists in the world in other ways. And to us, that's very comforting. It's interesting that we are starting to see more studies being done that are actually putting monitors on people and having them touch different materials, look at different materials, and monitoring how that's physiologically affecting us. But I think, in the next 10 years, we're going to know a lot more about this. And a lot of us just sense this right now, but it's not just magic, it's real.
I'd like to speak a little bit about the underfloor air, and then I really want to hear Bengani's input on it. It was a tough decision to make. In a typical building, the air conditioning system, it would output air from the ceiling. And we didn't necessarily like that system because in a timber building, the beauty comes from the ceiling. And so we wanted to show that ceiling off. We talked about the possibility of pumping in the air from under the floor. It's something that's been done many times. On the development side, I think we were a little reluctant to do it because we weren't familiar with it. Bengani really pushed it. Said, it'll keep your ceilings clean. It's a more efficient system. Keep your energy bills lower. It's a more comfortable system for the tenants because each tenant essentially has their own little air output right at their desk. So they can regulate the temperature at their own seating area. And then also there are a lot of health benefits. Frankly, the health benefits were about the lowest level concern that we had. But now, in the pandemic, it seems to be the one thing that resonates most when we show the building, other than the timber, is people want to know, why is this system healthier than an overhead air distribution system?
So I think that when we first started the project, we were looking at just doing a more traditional overhead VAV system. And I think it was in conversations with Bocapel and Lake Flato, looking at, well, what is the impact of that, when you have ductwork overhead, and what is it going to look like in the space, and how's that going to work? And then putting together some of the visuals that we did so that we got an understanding earlier in the design process as to what the space is going to look like when we had overhead ductwork. And so, you can imagine that, the space that we're in now, instead of having this sort of nice clean floor and the open ceiling where the only thing overhead is the sprinkler pipe, that you end up with, sheet metal ductwork, you're going to have piping, and you're going to have other, distribution throughout the entire space. And, it starts to clutter the space, especially as you get around closer to the core, and you can imagine up here on the 6th floor, larger duct suspended from the ceiling and really, starting to obstruct the views out to the high-level windows. And so, the underfloor system, pushes all that distribution under the floor, and it also pushes, all your electrical distribution. So when tenants come in, the only thing we're going to have overhead is, really conduit for any of the lighting that's overhead. Everything else will all come up from the floor, and that really cleaned up the space. And so, the system itself, the air is supplied from low level, and one of the great things about that from a comfort and indoor air quality perspective is that it lifts any pollutants and contaminants up and out of the space. And so that means that instead of mixing the air throughout, as is the case with a traditional system, you're really able to remove those contaminants from the occupants. And that's where it sort of moved to the forefront with the pandemic today. But even before the pandemic, there was still the health and wellness in buildings had really moved forward in the thinking of tenants, and especially we'd seen this with larger tech clients and some of the larger institutional clients across their portfolio. And then of course there's the controllability of it, that tenants or individuals will be able to control their devices and how much airflow they're able to get in each spot. I want to hear more and understand, what's like to build a mass timber project, because, they say it's like Lincoln logs, and you can just pick it up and you start putting it together. But what was that like to work through?
Yeah, so I get that question all the time, and I think people ask me all the time, what was the most complex or the biggest challenge that you had on the project? And I think everybody's thinking that they're going to hear the erection of the mass timber. But we spent so much time in early coordination and collaboration, and it's thanks to this team working so hard together early in design. Just the sheer amount of time we spent there just made it so much easier once we got into construction. So we knew in talking to structure craft that our core, our concrete core, which is the shear of the building, had to be perfect. And so we spent an inordinate amount of time making sure that that layout and supplementing that layout. We had a great concrete contractor in Keystone, but making sure that that layout was perfect, because the Canadians were working in millimeters. And those tolerances were a lot finer than what we generally work in when we're building concrete or steel structures. And so we got our tolerances down to, the core of this building is the most plumb and true 6 stories that we've ever constructed. And when the timber showed up, it literally went together like Lincoln logs. And we had a schedule of about 90 to 100 days to get all the timber erected. We hit the schedule. We never had to get out chainsaws and start cutting big pieces of mass timber. It never happened. And there's stories that structure craft will tell you about doing that. And so it all went together perfectly. I would say that the biggest challenge on this project was the skin. And so the skin on this building is very different in terms of other mass timber projects that I've studied. So not only were we on the cutting edge for mass timber, but putting brick on the exterior of a mass timber building, that much weight and carrying that much weight is what was always the biggest concern in the back of my mind. And it turned out to be the biggest challenge on the project. So that upfront coordination to make sure that all those steel members that needed to be supported by the timber, and they all move differently and react differently thermally. And then we've got glass and curtain wall and window wall and metal panels and so on and so on. It's a beautiful building, but bringing all that together was really a challenge.
Something that we haven't really talked about is the collaboration with structure craft, and that kind of how that rolled into this whole project, which was really, I thought, really helpful. I actually haven't done it another way, where you bid it to any wood contractor. Structure craft came in and they were our structural engineer, and they were our contractor underneath Byrne, right? And when we had a problem or detail, they're the ones who were doing the shop drawings, but they're also the ones doing the collaboration at the very beginning. And so that process, I felt, was really smooth.
Absolutely.
You know, our office has done other projects like CLT projects, and it was designed with just a structural engineer who doesn't actually physically build it, and there's been problems, you know. And the smooth process of working with someone who actually is building it and drawing it at the same time was, I thought it was really nice.
Yeah, and manufacturing it.
Yeah, and manufacturing it. Yeah, and so it was like a turnkey kind of situation.
It's really turnkey,
Yeah.
down to wrapping all the columns after they arrived on site to protect them for the rest of the construction duration.
Well, from the developer side, I think there's a lot of excitement. I think the fact that it's something new and it's something that's here in San Antonio, not Dallas, Houston, or Austin, that's a lot of excitement. And in terms of the tenant prospects who come out here, it's different. I think they look at it and say, this is something that could help us as we're trying to recruit and retain the best talent to this city and to their places of work. So it's exciting. For me, if I were to do it again, I would again want to put together a team that really wanted to do this kind of project, because there were so many issues that we had to think through collaboratively, that we needed the expertise of a contractor, an architectural group that's done over 100 million square feet of office, an extremely creative design architect, and frankly, a very innovative MEP that pushed the envelope, and when things got tough, were willing to back up and then put in the hard time, effort, and thought to make sure we did it correctly.
But it's been so fulfilling, and the sense of accomplishment is just greater than I think I've ever had on any other project to have completed it.